So here's another example of a curve sketching example. This one, we'll notice that the graph is going to look a little bit different. The pieces are going to be the same though, so we still want to look for the intercepts, the asymptotes, increasing, decreasing, max min, concavity, points of inflection. So we'll do that in that order. So I'll start with my intercepts again. So my y-intercept is going to be my function evaluated at 0, which will be negative 18 over negative 4. 9/2. So my y-intercept is going to be at the point 0, 4.5. And then I want to look for my x-intercepts. So that's going to be where my numerator is going to be equal to 0. So I'll actually write this in its factored form up here. That's going to be where x squared minus 9 is equal to 0. So it looks like we're going to have two x-intercepts. So one is going to be at the point negative 3, 0, and the other one's going to be at the point 3, 0. So then I want to know about my asymptotes. So it looks like I'm going to have two vertical asymptotes where my denominator is equal to 0. So x squared minus 4 is equal to 0. That's going to give me two asymptotes at plus and minus 2. And then I want to find out where my horizontal asymptotes are. So I'm going to go ahead and take the limit as x is approaching infinity of, I'll do the 2x squared minus 18 over x squared minus 4. So it looks like I want to divide by my highest power of x squared. And then I'll go ahead and simplify that. So my limit as x is approaching infinity of 2 minus 18 over x squared, and then 1 minus 4 over x squared. And then when I take the limit of each one of those pieces, I should be left with 2 over 1. So that will tell me that my horizontal asymptote is at y is equal to 2. All right, so now I want to find out where I'm increasing and decreasing. So I want to go ahead and take my derivative, again, using the quotient rule here. So I'll set my f as 2x squared minus 18. My f prime will be 4x. My g will be x squared minus 4. Looks like my g prime will be 2x. So that'll give me 4x times x squared minus 4, and then minus 2x times 2x squared minus 18. And then that will all be over x squared minus 4 squared. I'm going to clean that up a little bit. So that'll give me 4x cubed minus 16x minus 4x cubed plus 36x all over that denominator. Which I believe just leaves me with a 20x in the numerator and then the x squared minus 4 squared in the denominator. So I'm going to use this to find my critical numbers. So my critical numbers are going to come from both setting the denominator and the numerator equal to 0. So 20x is equal to 0 is going to give me a critical number at 0, and then setting x squared minus 4 squared equal to 0 is going to give me plus or minus 2. So I'll go ahead and set up a number line for y prime here. And then I'll go through and just test some values. So I'll do -3. I'm just going to go ahead and put that in my derivative up here. Again, I'm just looking for pluses and minuses. So numerator is going to be minus, denominator will be a plus. I'll test -1. Numerator will be a 0, denominator will be a plus, so it'll give me a minus. I'll test 1. Numerator will be a plus. Looks like denominator will also be a plus. And then 3, looks like my numerator will be a plus, denominator will be a plus. So that should give me a plus. So it looks like I do have some intervals of both increasing and decreasing on this one. I'm increasing from 0 to 2 and from 2 to infinity. I'm decreasing from negative infinity to negative 2, and negative 2 to 0. And it looks like I am going to be having a minimum here because I am changing signs, and I know that 0 is not going to be a vertical asymptote, so my minimum is going to be happening at the x value of 0, which we already know what that point is because that was our y-intercept. So that's going to be at the point 0, 9 halves, or 0, 4.5. So then I'm looking for concavity next, now that I know where I'm increasing, decreasing. So again, I want to take my derivative, so I'll call my f my 20x, I'll call my f prime 20. Looks like my g is going to be this x squared minus 4 squared. G prime, I'm going to need my chain rule here. So 2 times x squared minus 4 times 2x. Clean that up a little bit. So 4x times x squared minus 4. So my y double prime is going to be 20 times x squared minus 4 squared minus, that'll be 20x. Oh, no, sorry. 20 times 4x. So that'll give me, hang on, getting myself confused here. Nope, I was right. So 20x times 4x, that'll give me 80x squared times x squared minus 4. And then that'll all be over this quantity squared. So that'll be x squared minus 4 to the 4th. So I'm just going to clean things up a little bit up here. I do have a GCF to take out up here again. I'll take out a GCF, it looks like, of 20. And I definitely have a common factor of x squared minus 4. So that will leave me with just an x squared minus 4 for this term. And then that will leave me with minus just a 4x squared for my second term. And then as I'm cleaning that up, I'm noticing that one of my factors up here, again, is going to be canceling. So I'm left with a 20 on the outside. I'm going to clean up this stuff on the inside. That will leave me with a negative 3x squared minus 4. And then in the denominator, that will leave me with just 3 factors of this x squared minus 4. So that's my y double prime. So I'm looking for the critical numbers here to determine concavity and points of inflection. So that's going to come from where my numerator is equal to 0. So 20 times negative 3x squared minus 4. So negative 3x squared minus 4 is equal to 0. That's going to give me negative 3x squared equal to 4, which is actually going to tell me that x squared is going to be equal to negative 4/3 when I divide, which is not going to give me a real number here. So no critical numbers here. So it looks like my critical numbers are just going to come from this denominator. So x squared minus 4 is equal to 0. X squared is equal to 4. So it looks like my critical numbers for my second derivative are just going to be plus or minus 2. Or my second derivative, I should say. So set up a number line for a y double prime, put my critical numbers in there. So negative 2 and positive 2. And then I'm just going to go ahead and test some values. So I'll test negative 3 in my second derivative up here. Again, just looking for a sign. So 20 is obviously plus. This will be a minus. And then the denominator will be a plus. So that should give me a minus in between the first interval. Second one, I'll test 0. So 20 is obviously going to be a plus. That's going to be a minus, and then that will be a minus in my denominator. So that'll actually give me a plus for this interval. And then I'll test 3. So again, 20 is obviously positive. If I put a 3 in there, that'll be a negative. And if I put a 3 in the denominator, that'll be 9 minus 4 cubed is plus. So that'll give me a minus. All right, so now I know where I'm concave up and where I'm concave down. So concave up from negative 2 to 2, concave down from negative infinity to negative 2, and from 2 to infinity. And here, I actually don't have any points of inflection. I know that my pluses and minuses are changing here, but remember that negative 2 and positive 2, we said were vertical asymptotes. So points of inflection here, none. All right, so let's take a look to see what this graph is going to look like. So this one will look a little bit different than our first example. All right, so I know I have vertical asymptotes at plus or minus 2. And I know I have a horizontal asymptote at y is equal to 2. And then I know I have some intercepts. So my y-intercept is going to be at 0, 4.5. And I also know that my x-intercepts are going to be happening at negative 3, 0 and positive 3, 0. So then I'm just going to work my way from left to right. So I'm looking at this interval from negative infinity to negative 2. I know I'm decreasing on that interval, and I also know that I'm concave down. So decrease concave down is going to give me a graph that's going to look something like this, or a branch that looks something like this. I'll make sure it's passing through that x-intercept. So then I know that I am going to be, this is a minimum. Remember that we said that that was going to be a minimum point. So that means my graph would have to probably look something like this up here, but I just want to double check. From negative 2 to 0, I am decreasing, so decreasing. And from negative 2 to 2, I'm concave up. So that means that this entire interval is going to be concave up. So if I'm decreasing concave up, we're going to look something like that. And then from 0 to 2, we are increasing and concave up. So increasing concave up is going to look like that. And then my last interval here is going to be from 2 to infinity. 2 to infinity, we're increasing, and 2 to infinity, we're concave down. So increasing concave down is going to look something like this. And there is our graph. And we should be able to confirm this using our calculator if you wanted to as well, just to make sure that our graph seems reasonable. So if you did plug that into your calculator, that should be along the same lines of what your calculator will tell you the graph looks like. So I'll have you guys practice some on your own. Let me know if you have questions.